All right, so here's something you really need to know before you take this test and also for your final. We are going to be finding interest and using our continuous compound formula. So here's the formula that we're always going to use, so make sure that you actually write this down. A equals PE to the RT. So remember, E is that magical number. It's an irrational number. There is an E button on your calculator, so make sure you know where that is. So the A is the amount that's in your account. The P is the principal, and principal is what you start with. R is the rate of interest per year, right? And remember, you're going to be given this interest rate in a percent, and we first have to change that percent to a decimal, and then we can use it. And T is the time in years. So here's an example of this. Suppose you invest $1,050 at an annual interest rate of 5.5% compounded continuously. How much money to the nearest dollar will you have after 5 years? So I'm going to take my formula, right, and I always use the same formula, and I plug in the things that I know. Well, I start with $1,050, so that goes where the P is. E is the number itself. Here's where I changed my percentage into a decimal. So instead of 5.5%, remember, I take my decimal and move it twice. So it's 0.055. And we're talking about 5 years. So I can go ahead and I multiply these two values together, right? And then I can simplify. So then I take, following the rules of order of operations, I do my exponent first. So I go e to the 0.275. And then I multiply that times the principal, the amount that I originally invested. And I find out that I had approximately $1,382 in the account. I can also use this formula if it asks me how many years will I need to keep this in, or what percentage will I have to get to reach a certain amount. So remember, I just plug in the things that I'm given and find the things that I don't. So let's look at an example of this one too. So here's this example. How long will it take $3,000 to double if it is invested in an account that pays 3% interest compounded continuously? So first I look at my equation, right, and I use the same thing. A equals PE to the RT, and I plug in what I know. So I know I want to double my $3,000, so that becomes $6,000. I start with $3,000. E is my value. I've turned that 3% into a decimal, and I'm trying to find T. I'm trying to find that time value. So this looks a lot like those problems that we've been evaluating in our log problems. Okay, so I go ahead and I want to get everything with the E by itself, so I divide both sides by 3,000, which gives me 2 equals E to the 0.03t. Since I'm using E here, I'm going to be using my natural log, so I add my natural log to both sides. So I now have the natural log of 2 equals the natural log of E to the 0.03t. Then I know with my properties of logs, if I have an exponent, I can pull that exponent out front. And I know that the natural log of E is just 1, so I can simplify that a little bit further here, actually, without having to do as much math. So I know the natural log of E, since they're inverse operations, becomes 1, so I'm left with 0.03t equals the natural log of 2. Then to get t by itself, I just divide both sides by 0.03. So then in my calculator, I just find the natural log of 2 divided by 0.03, which gives me 23.1. So it'll take approximately 23 years for me to double my money in an account that pays 3%. So here you've seen this example of how I can use this same formula to find the amount of time. I can also do the same thing to find the rate. I just have to plug in what I know and then follow the steps of my logs from there.